these laws with this word, then you can easily do the sums. Okay. First law is when do we apply first law?
When in
terms of this, when the resultant force. Okay, let me write the F net in short instead of writing the full of this net force or resultant force. I'm going to use the term F net, abbreviation F net. When the net force is zero. Okay, this is the condition to apply Newton's first law. When the net force is zero, what will happen to an object? A moving object will
constant velocity.
A moving object will continue moving with same speed, same direction, which means constant velocity, and a resting object
will be at rest.
Yes, resting object will be at rest. This law is also called, what is the essence of this? What does this mean? This means that whatever the object is doing, it will continue doing so. If an object is moving with certain velocity v, it will continue moving. Velocity means speed as well as direction. If this is the direction of its initial travel, it will continue moving in the same direction with same speed. If this is 10 meters per second here also 10 meters per second, here 10, everywhere 10, it will continue without stopping. Okay, if the object is at rest here, it will continue to be at rest forever. That is what first law says. And what is the condition for an object to stay in whatever state it is in? Net force must be zero. What is net force? Does it mean that there are no forces? Does it mean that there are no forces?
No. Equal.
Okay.
In both directions.
Equal. The forces must be equal and opposite. So if this is 10 Newton, this also 10 Newton. If this is 20 Newton, vertical downward, vertical upward, maybe one or more, but the sum of the vertical also must be 50 Newton. If you have got a force here, same force in the opposite direction. Okay, that is net force zero. Now this is also called law of inertia. Inertia means staying where whatever state it is in. Okay, doesn't want to change, reluctance to change. That is law of inertia. Okay, now what is second law? Newton's N2 law. What is the condition to apply this? When there is a net force, when F net is not equal to zero, when there is a net force. Okay, when there is a net force, what will object do? Object will always accelerate. Accelerate in which direction? In the direction of net force. In the direction of net force. Now this gives you a famous equation of F net is equal to Ma. Okay, so from this only you get this one. What's third law?
Opposite and equal.
Every action has an equal and opposite reaction. Okay. Newton's third law is action. Every action has an equal and opposite reaction. Okay. This is Newton's third law. And what are the qualifications? What are the things that are needed to be for the again 3 pairs? All those things you have learned in your unit 1. So these are Newton's 3 laws. What we are going to concentrate more in this is second law. Okay, we are going to concentrate more. Here is second law. Second law gives you two important quantities. One is momentum. You have to answer, explain second law in terms of the word momentum. What is momentum? Momentum P is equal to
MV.
mass into velocity. Is momentum a scalar or vector?
Vector.
Vector. So any vector, I will be representing it by an arrow or by a bar. Is mass a vector?
No.
Velocity vector?
Vector.
Velocity is a vector. Okay. So since velocity is a vector, momentum is a vector. Okay. What do you understand when you hear the term momentum?
Moving object has some sort of momentum.
Exactly. Momentum means some form of energy which the moving object has. Okay. All moving objects have momentum. All moving objects. Momentum is a property of moving objects only. Okay. So if an object is moving, and assume that moving objects have momentum. P is momentum, which means that if an object is moving and if you want to stop it, what should you do? An object is moving. An object is already moving, so it has any moving object. Any object, big or small, any moving object has momentum, and if you want to stop this object, what should you do? You have to remove all the momentum out of it. How? Okay, you can remove all the momentum out of it. Okay, and how can you remove all the momentum? By applying an opposite force. Okay. Now, how can you change momentum? Momentum P can be changed only by an external force. External force. What do you mean by external force and internal force? External force
outside from the system.
and internal force of the system. Internal force of the system means the system that develops from within. You are not doing anything. For example, think about an explosive. Think about a bomb. Okay, if this is a bomb, it explodes on its own. Okay, so that force develops within the material. Right? So this is an internal force. Right? Now, what is an external force? If you assume that you are holding it in your hand and if you're throwing it, if you're throwing this bomb, that throwing force doesn't come within the bomb. That throwing force is an external force. But the force that actually caused this exploding, that is an internal force. You got a difference? Internal force is the force that is developed within the system. Okay. Within the system. System means what are the things involved? For another example I could give you is a gun and a bullet. The bullet is inside the gun, right? The bullet is inside the gun. So when you push the trigger, that you are applying only here. Okay, but what happens inside? The gun pushes the bullet forward. The gun pushes the bullet forward. So the bullet is inside the gun, and so the system is gun and the bullet. When the bullet pushes the gun forward, it goes forward. At the same time, the bullet pushes the gun backward. So these two forces are happening within the gun. They are internal forces. Okay. Okay. So also remember, only external forces can change the momentum. Another example, you think about a trolley. Assume that this is a trolley with wheels. This is another trolley with wheels. You are making them collide. So the system is, these two trolleys is a system. Okay. System. Now we are considering a system of trolleys. Trolley A and trolley B, they are part of a system. Now when they collide, A applies a force on B, B applies a force on A. So these two forces are internal forces. Is that okay?
Yes.
Now if this table is slightly slanted and you made the same experiment, there are two trolleys. This is made to this is somehow made to come up. This is made to go this way. They collide. These two are internal forces. But there is an external force here. Which is that force? Gravity, a component of gravity. Okay, here isn't there any gravity? There is a gravity, but gravity is acting vertically downward, and this gravity has no component in the horizontal direction. So if the surface is perfectly horizontal, gravity has no component. Why no component? What is the angle between them? If this is perfectly horizontal, gravity is acting exactly vertical, then this angle will be 90, and the component of gravity along this one will be cos 90. Cos 90 is 0. Therefore, this force has no component if the table is perfectly horizontal. But if the table on which you are doing the experiment is slightly vertical, slightly slanted, then this gravity will have a component in this direction. Yeah, this gravity will have a component in this direction as well as this in this direction. This component is an external force which is acting on this. Therefore, this will make your answer wrong because when we do this experiment, we don't want momentum experiment. We don't want any external forces. So you have to make sure that the table is perfectly horizontal. Okay, I'll teach about that more in detail when we learn about that. Okay, so momentum, all objects have momentum, and momentum can be changed only by an outside force. So if you don't want okay, now, yeah, what is the law of conservation of momentum? Law of conservation. Very, very useful and important one. Law of conservation of momentum. What is it?
Momentum before and collision is equal to after.
That's not complete.
Is equal to the momentum after the collision.
Collision provided
No external force is
no external force. Okay, that means that the total momentum before collision is equal to total momentum after collision, provided no external force acts on it. Fine. So that means momentum can be conserved, making sure that external forces are 0. Okay. Now this momentum, okay, this is an important concept. Mazherul, should you write it or it's in the textbook? Do you remember that?
It's in the textbook.
So I don't need to write it down. Okay, so you study this, very important. In a closed system, momentum before collision or explosion is equal to momentum after collision or explosion. So this conservation of momentum in and again remember one more thing. This is a law of conservation of linear momentum. What does this mean? Linear momentum.
1D collision.
In one direction only this momentum is conserved.
Yes.
If the momentum is conserved in this direction, it doesn't mean that momentum is conserved in this direction. This momentum has no part in this momentum. Okay, that is why this word linear is important. Momentum is conserved in one direction only. Okay, so I will give you questions based on this, then you will understand. Then what you have to, okay, then momentum is also conserved in explosion as well as collision. Collision in one direction. Okay, again collision. So when we apply questions to collision, remember this linear collision. What is collision and what are the type of collision? Collision, what are the types of collision? Number one, elastic collision. What is elastic collision?
No kinetic energy. Kinetic energy before and after the collision is same.
Yeah, in elastic collision, number one, law of, okay, in all collisions, law of conservation of momentum is applied. Okay, that means momentum is P before is equal to momentum after. If M1 and U1 is the initial mass, then you get M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. In one direction, how will you specify in one direction? Okay, assume that an object is moving in this way. If this is velocity, can I say, okay, can I say M1V? No, because this has two components, this way and this way. This is Vx, this is Vy. So what should I write? M1 in one direction. Okay, this is for general one. But since it is conserved only in one direction, you can write M1 U1 in the x direction plus M2 U2 in the x direction is equal to M1 V1 in the x direction plus M2 V2 in the x direction. Similarly, M1 U1 in the y direction, you have to do this separately, plus M2 U2 in the y direction is equal to M1 V1 in the y direction plus M2 V2 in the y direction. So if you have an object moving this way and assume that you have got an object moving this way, they may collide, but how will you apply conservation rules? This you break down into two. This also you break down into horizontal and vertical. Okay, you break down to horizontal and vertical. Now you match the horizontals, match the verticals, then you do it. Okay, I'll give you a sound to make you understand. Okay. Then so now if you do this. Okay, okay, let's do this question. Because M1, V1 and all you know already. Let's do this question. Again, how will you find U? Okay, now let me revise this one. If this is the initial velocity, how will you find if this angle is theta? How will you break it down to?
Yeah,
okay. Okay. So if this velocity is given to you, this is not in one direction. It has a component in the x as well as y. How will you find the x component? That
U
is
cos
u, x is equal to
U cos theta.
u cos theta,
And
and
y is equal to
u
y sin
y
theta.
is equal to u
U
sin theta. Okay, remember this to do the calculation. This is how we take it. Okay, now let's do this sum. Apply, you have to apply law of conservation of momentum. You have got two hockey pucks. One is this A, has a mass of okay, there are two pucks, each has a mass of 0.1 kg. Assume the mass is same for both. Now this A is moving horizontally with a velocity of 5 meter per second, collides with B, which is at rest. How do I show B is at rest? B is equal, so it's U is equal to 0. Okay, B is at rest. Now they collide, A and B collide. After collision, A goes this way, B goes this way. Okay, this angle is 30 degree. A goes this way with 30 degree, and here it goes with an angle theta. And A goes with a speed of 2 meter per second. You don't know what is the speed with which V is going, V. Okay. Question is, calculate this angle theta, calculate theta, and what velocity with which it goes. Have you understood? Now,
Yes.
First of all, is it a one dimensional collision or two dimensional collision?
Two dimensional.
Two dimensional collision. Why? Because two dimensional means you will have x axis movement as well as y axis movement. Okay, even though this is not given directly, one of the motion is slanting, which means this has a component, these two. If another one has a motion this way, that means this is a two-dimensional motion. Okay, these two shows that it's a two-dimensional motion. In the case of two-dimensional motion, break it down along x and y. Now let's do this one. Okay, so you have to do for x separately, you will get an equation. Do for y separately, you will get another equation. Then you solve to find the two unknowns. So here, taking it in the x direction. Okay, in the x direction, what is the formula? M1, U1, U1x. U1x means U1 cos theta. And this cos theta or sin theta depends on what angle is given. If this angle is given, then the cos theta, this won't be cos theta. So I will write U1x. Okay. Plus M2, U2 in the x direction should be equal to M1, V1 in the x direction plus M2, V2 in the x direction. This is before collision, this is after collision. Now put the values. All masses are 0.1. So 0.1 into what is U1x? Is U1 purely in the x direction? This is U1. This is U2. Is U1 purely in the x direction? Yes. So into 5. Okay, you can direct, there is no cos or sin factor. Plus, what is M2, U2? What is U2? 0. Okay, U2 is 0 because it is at rest. So, and again, so this is 0 is equal to. This is V1, let's take, this is V2. So what is V1x in the horizontal direction? This angle is theta. So this one will be cos theta. 0.1 into V1 is 2 cos 30 degree. Mazherul understood how to apply? Don't take only 2. Since we are considering x, take the component of 2 in the x direction. Plus M2. M2 is also 0.1 into what is this V2? Let's take this as V2. We want V component of V2 in the X direction. So this will be V2. Here the V2 is VB cos theta. Now you simplify this, you will get an equation that means 0.5 is equal to, how much is this? Find out and tell me. Yes, we can cancel them out because both equations you have. We can cancel that out, no problem. So 5 is equal to
Root 3.
2 cos 30. Huh?
Root 3. Root 3.
Root 3. Root 3 means how much?
1.732.
1.73. So 1.73 plus VB cos theta. So therefore VB cos theta is equal to 5 minus 1.73.
Yes.
3.27. 3.27. This is equation 1.
Now we have to take the vertical component.
You take this one here. Okay, fine. Now taking the, now here what we have to write in the equation is that considering the law, okay, the law of conservation along the x-axis, you have to write in full. You do this, okay, and applying law of conservation along the y-axis, m1 u1y plus m2 u2y should be equal to m1 v1y plus m2 v2y. m1 u1y will be, you can cancel since all the masses are same, you can cancel them out. Okay, you can cancel that out. So fine. So what is left is, let us put 0.1 into, now this is purely in the x-axis. So what is its y component?
0.
0. Pressure understood? This is purely in the x-axis. Its vertical component is 0 because this angle is 90, cos 90 is 0. 0 plus this is already 0 because V2 is 0. Ashar, are you following it? This one. This one, because V itself is 0. VB is at rest. This is already at rest. Its initial velocity is 0. So it has obviously no component. Is equal to M1, 0.1 into V1y. V1y is, this is V1, y component is sine 30. V1 is 2 sine 30 plus 0.1 into VB sine theta. Simplify, 0 is equal to, we can cancel this 0, 1, okay, 0.1 you can cancel, 2 sine 30. 2 sine 30 is
2 sine 30 is 2. Oh no, it's 2 sine 30. 30 is 1. Oh, it's
1. 1 plus 0.1 gone. VB sine theta. Okay, one more thing. See, look here. You look here. We have taken like momentum is a vector quantity because velocity is a vector quantity. This we have taken as positive. Therefore, this must be taken as negative. But here for the cos, why didn't we take? Because this cos component is here. This cos component also is in the same direction. Therefore, we added here. Okay, cos component or the horizontal component at the same direction, therefore we added here. They are in the opposite direction, therefore you have to put a minus sign here. Okay, momentum is a vector, so wherever the directions are opposite, make sure that you put minus. So this will be 1 minus VB is equal to 0. Therefore, VB sine theta is equal to 1. This is the equation 2. This was equation 1. Now what to do? Now what to do? Two
Then we have to
equations.
substitute.
The easy one is you do equation 1 by 2.
Divide, yes.
No, not 1 by 2, 2 by 1. Equation 2 by 1. So what is that? VB sine theta by VB cos theta is equal to 1 by 3.27. Now VB gone. Huh? See, look here, what is VB? Now what are we doing? Equation 2. What is equation 2? VB sine theta is equal to 1. Right. VB sine theta is equal to 1. This equation 2 divided by equation 1. Equation 1 is VB cos theta is equal to this much. So VB sine theta by VB cos theta equation is equal to 1 by that. Why do we do this? Because now we can eliminate this VB. Now what is sine theta by cos theta?
Sine theta by cos theta is 10, I guess.
Tan theta. So what you get? Tan theta is equal to 1 by 3.27.
17 is the answer?
1 point.
No, theta is 17, I'm saying.
Theta is?
17.
17. Okay, 16 point something. Tan theta is equal to something. Theta is equal to tan inverse. This answer is around 16.7 degree.
Yes.
So this is a very, very important technique which you have to follow for different situations. If you have got one sign, this one, then you cancel that, you will get tan, you can find that. Now since you know theta, put it in this equation because theta is equal to 17. If you put it in the first equation, VB cos 17 is equal to 3.27. Therefore, you find out.
Okay.
Okay. So this is the important. So this you do it now. I'll give you one more sum. I'll give you one more sum just now. I'll put it in the group. You do that after copying this one down. Okay. No. This is classwork. I want you to do this one now. Just one question. Right, and both the objects have velocities directed. Theta is equal to 30 degree on either side of the original line of motion of the first object. This is the line of motion of the first object. So that means from here 30 degree this way one object goes, 30 degree this way another object goes. Have you understood? This is the diagram. So let this be M1, say 5 kg goes this way, 2.5 kg goes this way. Now, okay, what are their final speeds? That means you have to find this V. Say V1, you have to find this speed, say V2. You have, okay, this V1 and V2 are not the horizontal or vertical. V1 is the sum of these two. Sum of these two is V1. V2 is the sum of this as well as this. Okay. So again, what you do? Break it down. Do horizontal conservation. Do vertical conservation. You will get two equations. You will get this component. You will get this component. You will get. Find the sum of that. Should I show you? Okay.
We can try.
So what is the velocity of the first one?
Which velocity?
Okay, see, look here, I'll show you.
I'm doing it. I'm still doing it.
Do it. Got it? Okay, look here. I will tell you these steps, then you do it at home. Did you get this equation? 5 into 4.5, when you take the x direction, is equal to 5 v1 cos 30 plus 2.5 v2 cos 30. Did you write this?
Yes.
Which is equal to, this answer you can find 5 cos 30. Okay, that means 22.5 is equal to 5 cos 30 is 4.33 v1 plus 2.5 cos 30 is 2.16 v2. Equation 1. Now, second, considering in the y direction, vertically here 0. 0 is equal to 5 v1 sin 30 minus 2.5 v2 sin 30. So 0 is equal to 5 sin 30 is 2.5. So 2.5 v1 minus 2.5 sin 30 is 1.25 v2. So 2.5 v1 is equal to 1.5 v2. You can cancel this out too, and you can write v1 is equal to v2 by 2. Now what to do? Put this relation in the first equation. Where you got v1, you put v2 by 2, or where you got v2, you put 2v1. Then you find the answer of any one, that is v1. Similarly, you put the value for v1 in the other equation, then you find v2. Only this much is physics, rest is mathematics. Okay, I will give you the answer. You check it if you are getting this. Okay, v1 should be 2.59 meter per second, and v2 should be 5.196 meter per second. Okay, write these answers down and see if you are getting. Okay, please try it at home.
Okay, Miss, we can move on now.
Okay, now the other part of the question is it an elastic collision or inelastic collision? What is an elastic collision? What is an inelastic collision? There are two kinds of collisions are of two types. Number one, elastic collision. In elastic collision, in all collisions, kinetic energy is, in all collisions, momentum is conserved. What do you mean by momentum is conserved? Momentum P is conserved. What does this mean? They may ask you simple like this, momentum is conserved. What does that mean? This means that total momentum before, total sum of the moments before in any one direction is equal to sum of the momentum after. This is what you mean by momentum is conserved. In elastic collision, in addition to this kinetic energy, not clear. Okay. In elastic collision, in addition to these two, kinetic energy. Okay, that means half mv square. Kinetic energy is also conserved. What does this mean? This means that kinetic energy, sum of the kinetic energy before collision is equal to, you understand what you mean by sigma? What does this mean? This means sum. Okay, sum of the kinetic energy of all kinetic energy after collision. Okay. Now there is an important thing that you have to remember. Momentum is vector quantity. So you have to take X and Y calculations separately. Okay, this you have to remember because momentum is a vector. Is kinetic energy a vector?
No, it's a scalar.
Energy is a scalar quantity. For kinetic energy, should you take the X and Y components? No. You have to take the full component. For example, if this is V, if this is Vx, if this is Vy, Vx and Vy should be taken for momentum and V should be taken for kinetic energy. Energies are scalar. Energy is a scalar quantity. Momentum is a vector quantity because it has velocity and this velocity is a vector quantity. Momentum is in certain direction. Because if the object is moving in this direction, it has momentum in this direction only because it's moving in this direction. But the kinetic energy does not, no, it does not have direction. It's a scalar quantity. You want to know how much energy it has, that's all. Okay, even though it has V, it is the speed that we are talking about, not the velocity. So this is the speed. Okay, this is the speed that we are considering, not the velocity. So this is an important point. Please write it down here. X and Y components that you calculate separately means take Vx, Vy separately. Okay, for momentum calculations. For kinetic energies, what we have to do? Take the full, that means V, not Vx or Vy. Why? Because the energy is a scalar quantity. So we have to take full. Momentum, you take it partially because momentum is conserved in one direction only. Very important concept, okay?
That's about it.
Okay. Now, in this question, they are asking you whether this is elastic or inelastic. Okay, now let me complete this first. So in elastic collision, both momentum and kinetic energy are conserved. But in inelastic collision, okay, let this be A. So A has both the things conserved. B, inelastic. In inelastic collision, is momentum conserved?
Yes.
Is conserved in all collisions. Okay, this is only one thing that we can definitely say. Whether an object is colliding, momentum is conserved and momentum is conserved in one direction. Okay, so that's why please write, instead of to make that one direction, you write linear momentum. Okay, linear momentum is conserved. Here also you write linear momentum. Okay, linear or Px or Py, linear momentum. This word also you always attach, so you will not remember. Linear momentum is conserved, but kinetic energy is not conserved. What do you mean by conserved measure? Conserved means kinetic energy before is not equal to kinetic energy after. Okay, this is what you mean by not conserved. If it is conserved, P before is equal to P after. This is what you mean by conserved. Not conserved means they are different. So for this, you take the full V value. This you take components. Fine. Now here what you do? Full half U1 square, no X or Y, plus half M2 U2 square is not equal to half M1 V1 square plus half M2 V2 square. This is what you mean by not conserved. For this, huh? For this, now here they are not equal. Now what they may ask you if it is elastic or inelastic. You calculate the total kinetic energy before. You calculate the total kinetic energy after. If they are not equal, you say inelastic. If they are equal, you say elastic. Okay. Now, there is a question in your text. It's a very, very important question. So let me make you do one more thing. One more. I gave you one question for homework, okay? Did you see that? I gave you one question for homework. Let me give you a question from the textbook. There's an example given in your textbook to calculate whether it is elastic or inelastic. And the one which I gave you just now, 130-degree angle, that you calculate. Okay, I'll just tell you. I gave you one question, right? V1 and V2, and I told you to do it as homework. That photo you do totally as homework. And I made you do one patient partially, and since you were taking a lot of time, I told you to complete at home. In that one, you calculate kinetic energy. Now I will give you V1 value. Okay, V1 value is 2.5981 and V2 is 5.1962. These are the values which you should get after doing. Now with this value, you check whether this is elastic or inelastic. Okay, this particular one, you check. Find kinetic not clear, not clear. These are the answers that you should be getting. With these values, you find out the kinetic energy before and kinetic energy after, and then you check whether they are elastic or inelastic now. Remember, this is not X or Y, this is total. This V1 is equal to square root of V1 X square plus V2. Now in the X and Y direction, V1 Y square. Okay, this is V1 X, this is V1 Y, this is V1. So this is equal to square root of this one. This is all what you know. Now, half M1, what was M1? 5 into V1 square, 2.5981 square, plus the other one was 0. U2 was 0. Is equal to, no, this is a, no, not this value. What was V1? V1 was 4.5. 4.5 square plus 0 is equal to half into 5 into 2.591 square plus half into 2.5 into 5.1962 square. You do this and check whether they are equal or not. Whether this side is equal to this side. Okay? That's that.
Non-contact and contact.
Relativistic particle means this is a word which is derived from relativity, law of relativity, Newton's law of relativity. Okay, relativistic particle is a particle that moves with a speed closer to speed of light. Because Newton says that if any particle moves closer to the speed of light, it doesn't obey many of the things which you have learned so far. Okay, what you are learning, for example, mass, you are saying that mass is constant, right? All these things, all these laws are applicable to a non-relativistic particle. So what is a non-relativistic particle? Particle which is moving not closer to the speed of light, or a particle that is moving with very low speed compared to speed of light. What is the speed of light? What is the speed of light?
3 into 10 to the power 8.
3 into 10 to the power of 8 meter per second. Okay, so all particles which are moving closer to 3.8 meter per second are called relativistic particles. Non-relativistic particles are those which are going slowly. And we have been learning about non-relativistic particles. But when you learn about subatomic particles, you will see that many particles move with their speed closer to speed of light. Fine. And for non-relativistic particle, you have learned two equations. One is P momentum is equal to mass into velocity. Also, you have learned kinetic energy. Say Ek is equal to half mv square. Okay, where we assume that mass is constant. This is one important difference between relativistic and non-relative. And this is a consequence of its speed. Now, you can use these two because many a times we cannot find the momentum directly when we talk about subatomic particles. Subatomic particles means protons and the things made, the things in proton. What are the things in proton? Quarks. Okay, all these things. So we will learn about that in detail in this unit itself, but towards the end of this one. So when we learn about that, these equations sometimes will be very difficult to use. So we have an equation combining these two, and we can write, see, look here, from P is equal to mv, what is V? V is equal to P by M. Put that in this equation. Ek is equal to half M into what is V? V is P square by M square. Now cancel this M and this out. So what do we get? Ek is equal to half P square by M. This equation, because momentum, mass, kinetic energy. You don't need to find the individual velocities. It is difficult to find because if you know the Heisenberg's uncertainty principle, you will learn that it is difficult to find the velocity at any time. But we can calculate the momentum from some other concepts. So this formula, Ek is equal to half P square by M, or P square is equal to 2m into kinetic energy, or P is equal to square root of 2m into kinetic energy. This is a very, very powerful formula when you learn about subatomic particles. Okay. This derivation is important. Please take down this derivation. For subatomic particles, they may be moving, they may be relativistic, they may not be relativistic. But for them, this equation is very, very helpful. Okay, so this derivation is important. Then there is something. Now they will give you kinetic energy. You have to calculate. Now, did you make a formula chart? Last time you did not make. This time, from the beginning itself, let's start making. You have to write in the formula chart law of conservation of momentum. What is elastic collision? Okay, and what is this equation? All these equations, please make a special paper and keep writing. Whenever you learn a new equation, keep writing. Okay, the day before the exam, you will have time only to revise this. Okay, next class I will ask you to check. In the next class, I will check that. Now, this kinetic energy, what is the unit of kinetic energy that you know? For the normal particles, normal objects, what is the unit of kinetic energy? Yeah? Joule. But when we talk about subatomic particles, this joule is a large quantity. So we use a small unit of energy. I did this in the last unit.
Electron volt.
Electron volt, 1 eV. Okay. Is equal to how many joules?
1.6 into 10 to the power minus
19 joules. Okay, so When we use this equation, sometimes the energies of subatomic particles are also given in EVs. Make sure that you convert into joules and then EVs. Okay. Then there are few exercises given in your textbook. Will you do them on your own?
Yes.
Okay, please do them on your own. And if you don't get it, then you let me know. A checkpoint on page 5. Huh? All the checkpoint questions on page 5. If you don't get it, then you must do it and you have to show me. Next class I will ask you to show. Huh?
Okay.
Okay, checkpoint questions on page 5. Then this one. There are questions. There are some questions on 5A, more on collision, then collision vectors. Okay, then I ask you this type of question. Okay, if a particle has a component in this way, if this is V, say Vx, and if this is, okay, no, this is not Vx. This is not Vx. This is not Vx. They may ask you if this is Vx and some other indication that this is Vy. How will you find V? By vector diagram. Vector diagram, not it's blurred. Is it okay now? It's still blurred. Okay. By vector diagram, how will you show this? How will you find the resultant velocity? By calculations, you know. Calculation V is equal to square root of Vx square plus Vy square. By vector diagram, how will you show the resultant? By triangular law, remember? Huh? By
Yes.
triangular law, either Vx this way, Vy this way, then this is V. This type of question also comes usually.
Okay.
Okay, now this is the one. Can you take page 8? Deep sea collision. Deep sea collision, page 8. Example, on July 2005 and all, one NASA testing. Yeah, there's an example described over here.
Yes.
Okay, they are mentioning about this vector diagram. They have given you this, they have given you this, and you have to find this. Or sometimes they will give you this, they will give you total, you will have to find out this. Okay, so please go through that one also and see if you get it.
Okay.
Yeah, there is not much in this. Mainly this collision and conservation in two-dimensional one. That is the important topic in this chapter, more on collisions. And if you get time, please do the end of text questions also. When are you having the next class? Today is
Thursday.
Monday. Thursday I have a class. Can we have it on Wednesday?
Yeah, okay.
Wednesday, okay. Thursday, Friday, and all I'm busy. So Wednesday 27th, I will be taking class. Okay.
Okay. Miss, can we talk about the payments, the previous payment?
Yes. You have calculated the number, whatever you calculate that you pay.
I did 11 class and I did 10 classes.
Okay, fine. So whenever you're free, you can come. Do you want my location?
Yeah, it would be better if you can send us on WhatsApp.
No. I am in India now because I took vaccine from here. They are not allowing us to come there. I'll be coming there in 1 or 2 months when they allow us. My husband is there at home. You can come there and pay. No problem.
Send us the location.
Okay. I'll send you the location. All right. Yes, it's in Hara. It's in Hara. Per class 100, I told you, no? Because this is I have to teach you a lot in one day, right? It's not the regular class. If it's a regular, I would be charging less. But since it is a very quickly, I have to finish.
Miss, can you pay 90?
90?
Yeah, it will be helpful.
Okay. You pay 90. Huh?
Thank you, Miss.
But don't say this to others because others I am charging.
Yeah, okay.
They're giving me 100. Huh?
Okay.
All right. Huh?
Yeah, it'll still be too much.
Pardon me?
And Miss, what about this, like the classes we're doing? What will be the cost per class?
Okay,
like
for
now?
that also you give 90. Huh? This is, huh? Yes? All right. Okay, but you get a good grade. That is more important. Huh?
Okay.
I don't know about your last. Okay, this we have how many months? October almost done now. November. When is your exam?
2 months.
November.
January.
January. Okay, at least 2 months. But here in this one, there are a lot of new things which you have to learn. It's not like AS. AS was easy. So please do concentrate. Do follow what exactly I said.
Yeah. Okay.
Okay, and the homeworks which I give you before the class, as far as possible, do it and send me pictures.
Okay.
And if you don't understand, you have to make sure that I clear them. I may forget. Okay, any question that you don't understand prior to my teaching, you may stop me and say you haven't understood this. So you clear and go every concept. Okay.
Yeah. Okay.
All right. Okay.
Right.
So now
Just send us the pictures, all right, of the notes.
Okay. After, but today I didn't write much neatly. But anyway,
It's okay.
whatever I have written, I will. So in this chapter, these 2 days. Now, how many subjects are you writing in this one?
Chemistry.
January?
I'm writing chemistry and physics.
Two. Okay, you've got time. 3. Physics, chemistry, and physics. Oh, physics, statistics, and math. Oh, okay. Have you statistics? Quite a lot to study, or it's in maths only, right?
Yeah, it's in the maths.
Okay, but still, I'm not saying that you have only less to study. You do have much to study if you want to get A+. You've got quite a lot to study. Anyway, don't give more importance to physics. Physics is easy to score mark if you understand compared to other subjects. Okay, because it is because if you practice enough, you can easily score mark. Now, so in this one, you do as much as questions as possible. If you don't get it, I will clear it in the next class. Now, this we could finish quickly because it was a continuation of what you learned in your AS level. Next, I'll just start with the next chapter, maybe 15 minutes left, maybe 20 minutes. Okay, I'll just start with. Or should I start with a new one, or should I make you do one question? What should I do? Yeah, I will start a new one, but you have to tell me that you have to do those questions and you have to inform me what you don't understand. Circular motion. This is totally new to you.